Hello everyone and welcome to Mathssteps. Today we are going to learn how to describe the unshaded region in the graph. And this is the opposite to what I've done in my previous videos, because we are going to get given the shaded regions and we are going to find the inequalities that represents the wanted area. So let's have a look at one example. So here I prepared the steps for you to follow when you do your independent work. And this is the example number 1. So if you look at the shaded area, the shaded and the unshaded area are, let's say, being divided by a dotted line. Dotted line means we deal with an equality that is either bigger than or smaller than. So it's not a solid line. Okay, and then it's on the 6. It's now the equation of the line. So we start with the equation of the line first. Equation of the line is what it is x actually. It is x equals 6. X equals 6. Now the wanted area is going to be this bit here. All this one wanted area, and we need to find the inequality that represents the wanted area. Now, if you take a point on this wanted area, which I usually like to take this point here always, the 1, 0 point. And then see, 1 is smaller than 6. So 1 is smaller than 6, of course. If you take another point, point 3 here, for example, 3 is smaller than 6. And so the equation or the inequality for the wanted area is going to be x smaller than 6. All right, not smaller than and equal, because the line is a dotted line, smaller than 6. So here it is, x smaller than 6. So this is the strategy. Let's have a look at another example. Describe the unshaded region. Now here we are dealing with a dotted, it's not a dotted line, with a solid line. Solid line. Now equation of this solid line is actually y equals -2. Now we need to describe the unshaded region. So all of this region here below the y equals -2. Now if you take a point, and I'd like to take this point here, -3. -3 is actually smaller than -2. So the inequality, because I'm dealing with a solid line as well, is going to be y smaller and equal than -2. So all this, the unshaded region, the inequality that represents this one is y smaller and equal than -2. Here you go. Just like that. Next one. Now, again, it's a solid line. First thing first, we need to find the equation of the solid line. And how do we do it? We start with the general formula of a straight line is mx plus c. C in this case, and you see the y-intercept is -3. So c equals -3, okay? And m is, if you build a right angle triangle here, it's going to be 1 to the right and 1 up. So rise over run, so m equals 1. So the equation is going to look like this. Y equals x -3. So this is the equation of the line. But it's a solid line. So let's find out. Take a point, this point here, 0, 1, 0, this point here. And let's try. 0.10, let's substitute. So y is 0. And the other side, we substitute 1 -3. So leave this area in the middle, leave it blank. Let's make an empty square. And then you put the inequality inside, right? So 0 something, 1 -3 is actually -2. And 0 is bigger than -2, isn't it? 0 is bigger than -2. That means if you try the same thing with other points on this wanted area, as we call, or the unshaded area, you are going to find out exactly the same thing. So all the points satisfied are bigger than -2, are going to be bigger than -2. And that means that the inequality for the unshaded region is going to be y bigger and equal now? Equal because it's a solid line. Then x minus 3. And this is how you find the inequality of the unshaded region. There you go. Y bigger and equals than x minus 3. Okay, here we have to find out two inequalities because we have two shaded areas. Now, the first one, we start with this one. This one here is a dotted line. The equation of this dotted line is y equals, you see, equals 2. And the unshaded area, if you take this point here, y equals 1, so it's smaller than 2. So the area, the wanted area, it is going to be represented, so the wanted area is going to be represented by this inequality, y smaller than 2. All right? Now, we need to find the equation of the other straight line, which in this case is it's a solid line. So the equation of this one, we begin from mx, y equals mx plus c. C is minus 1, so minus 1 mx. If you build the right angle triangle, how much is m? 1 over 1, m is 1. So the equation is going to look like this, y equals x minus 1. Now, we are going to find out if one point on the unshaded area satisfies. So what does it satisfy? Is it going to be bigger than this one or smaller? So we have to substitute. So I'm going to take, for example, I'm going to take this point here. This point, the coordinates of this point are minus 1 and 0. And let's try. Let's substitute minus 1 and a 0. So 0, y is 0. Leave the inequality sign blank. X is minus 1, minus 1, minus 1, right? So we're going to have 0, something, minus 2. And how does 0 compare to minus 2? 0 is bigger than minus 2, all right? So the unwanted area, the equation of the unwanted area is going to be y bigger and equal than, now it's time to write the equation, and x minus 1. There you go. So both these inequalities represent or describe the unshaded region. All right? Now, here is something for you to work independently. So remember, find the equation of a straight line and then try to figure out by substituting the unshaded area. How does it satisfy? So what does it satisfy? Same one. Here, you need to find the equation of a straight line. It is going to be through identifying the c, so the y-intercept, which in this case is minus 5, and the gradient. By building this right angle triangle, I can see the gradient is going to be 1, and then find out again by substituting, by finding, using one point of the unshaded area, substituting and finding out what does that satisfy. Just follow exactly the examples that I showed you before. So thank you very much for watching Mathssteps. Thank you for supporting Mathssteps, and have a lovely day. Bye-bye.